All right, in this video, we're going to take a look at acid-base neutralization reactions. So we have hopefully seen previously in a demonstration that when you mix some sodium hydroxide with some hydrochloric acid, that the pH will change. And we refer to this as an acid-base neutralization reaction. And this is actually not a new type of reaction. This is a reaction that we've seen before back in our reactions unit. It's a double displacement reaction. So we've got two compounds combining together. And whenever you have a compound plus a compound, you want to recognize that that might be a double displacement reaction. And down here is just a general reminder of that reaction pattern. So what happens in these double displacement reactions is the first element of one compound switches places with the first element of the other compound. And so like in this case, our elements that are switching places are the sodium and the hydrogen. So the sodium is going to go where the hydrogen was, and it's going to stick to the chlorine. And then the hydrogen is going to go where the sodium was, and so it's going to be with the hydroxide. So they just kind of switched partners, so we formed two new compounds. Whenever you are writing formulas for compounds, you should always consider the charges of the ions you're combining together. So sodium, look on your periodic table, it's got a +1 charge, chlorine's a -1 charge. So no subscripts needed there. So I'm going to go back and erase those charges now. Okay, because I was just kind of double checking to make sure this compound is neutral. And then if you look on a periodic table, hydrogen has a +1 charge and hydroxide has a -1 charge. So you might remember from our earlier reactions unit, there were some polyatomic ions that we want to be familiar with. And I'm just going to quickly write those down off to the side. You can look back at your reference sheet from Unit 7 to remind yourself of those. Those are the main ones we'll be seeing here. Maybe NH4+. Okay. So hydrogen and hydroxide, those charged up to 0, so no subscripts needed. But you might notice this and say, hey, wait, hydrogen hydroxide, that's 2 H's and an O, that's H2O. So look at what we just did here. We actually formed water. So we typically will write this as H2O as opposed to HOH. So we'll notice that whenever we have an acid-base double displacement reaction, one of the products of this reaction is going to be water. And that's because the hydrogen from the acid is going to combine with the hydroxide from the base, and they're going to form water. So let's take a look at some more examples of this. So acid plus base is going to make some compound and water. And here's another vocab term for you. This other compound that we form, we call this salt. And you might think, oh, I know what salt is, right? That's what I put on my food at night. That is an example of, this is table salt, which is sodium chloride. That is the salt that we are familiar with. And so that was the salt that was produced in this reaction right here between HCl and NaOH. But if we have other acid-base reactions, we'd form different compounds. Like in this case, we formed potassium nitrate. In this case, we formed lithium bromide. So we would also call these salts. So it's kind of like with sugar. We know there's a variety of different sugars. You can have sucrose, fructose, glucose, but we call them all sugar. Same thing here with salts. There's a variety of different types of salts out there. And yeah, table salt's the one that we're probably most familiar with. So you can stop here now and take a look at page 16 and do some practice problems with this. There's a few practice problems up here at the top. So whenever we're predicting products for this reaction, remember it's a double displacement. So the first elements are going to swap places with each other. So the sodium is going to go over where the hydrogen used to be, and then the hydrogen is going to combine with the hydroxide. And we typically will write that as water. So I made liquid water. And then this right here, sodium bromide, sodium's got a +1 charge, bromide's got a -1 charge, so no subscripts needed there. Okay, so that's my compound. We can also apply our solubility rules that we learned in our reaction units as well to figure out that this salt is going to be soluble, so it's going to be aqueous. And that you can just look back at your solubility rules to figure that out. Let's skip down and look at C. Look at this example. So where the hydrogen and the sodium are switching places. So the sodium goes with the sulfate, and then the hydrogen goes with the hydroxide to form water. So one of the products is always a given. You're always making water. And then let's come back here to this one, sodium and sulfate. we want to, remember, whenever writing a formula, you want to consider the charges. And sulfate is one of those polyatomic ions we learned in our reactions unit. So it has a -2 charge. Sodium has a +1 charge. So if you remember this crisscross method, boom, boom, boom. So this is actually going to be Na2SO4. So that one got kind of messy. Let me rewrite that. It's going to be Na2SO4 plus H2O. Those are going to be my products of this reaction. And then we're going to need to balance it. I'll just rewrite this over here. Okay, and so I've got Na2SO4 and I've got H2O. Notice how I have 2 sodiums over here now. So I need to balance this. I'm going to put a 2 over here. So I got 2 sodiums there. And then I'm going to put a 2 over here is going to balance out my number of hydrogens. So there's that one. So it's the same pattern again that we did with in our reactions unit. They're just double displacement reactions. And again, if you look at your solubility rules, you can figure out this is going to be soluble. And then the salt is the compound that is made that is non-water. So like in A, it's NaBr, which if you want to write the name for it, that's sodium bromide. And then in C, that's Na2SO4, which is sodium sulfate.